Absolutely. This is the last video we're going to have in Chapter P. This is P5, Part 2, Polynomial Inequalities and Rational Inequalities. Here is an example of a polynomial inequality. The polynomial part is easy to spot. This is a trinomial, x squared minus x minus 6. This is a quadratic. The inequality part is also easy to spot, greater than 0. Now what we're going to do is we're going to factor this side. We have lots of options available to us, but this is a pretty easy one to factor. So we would say x 3, 2, negative 3, positive 2 is greater than 0. At this point, though, you may be a little confused about what to do here. So what we want to do is we want to find what are called critical numbers. And you may remember this term from Algebra 2, critical numbers. Those would be the solutions if this were an equation. So our critical numbers here are 3 and negative 2. And what we know is at negative 2 and 3, something happens to this polynomial. Now, I'm going to draw this for you just on a number line. Here is a negative 2, and here is a 3, and I'm going to put some dots here. And I'm going to show you how we now have this divided into 3 parts. We have the part from negative infinity up to negative 2. We have the part between negative 2 and 3. And we have the part from 3 to positive infinity. Okay, now does everybody see how I just took those 2 solution points, put them on a number line, and said, hey, we got 3 parts. We got this part here, we got this part here, we got this part here. Now what we want to do is we want to pick another point that is in that range, and we want to see if it makes this statement true. In other words, if I pick apart a point in this part, does it make this value greater than 0? If I pick apart here, does it make this value greater than 0? And if I pick a point over here, does it make that solution positive, greater than 0? Okay, so let's pick some critical points, some test points. My test point down here is going to be, how about negative 5? So I'm going to test negative 5. All right, when I test negative 5, this is what I get. I get 25 plus minus negative 5 plus 5 minus 6, and that's supposed to be greater than 0. Well, I think you can see that's 30 minus 6, 24 is greater than 0. That is true. Okay? Now, let's test a point between negative 2 and positive 3. I'm going to test 0. If I test 0, I'm going to get, again, back to the original, 0 squared minus 0 minus 6 is greater than 0. That's negative 6 is greater than 0. That is clearly false. And third test point, I'm going to pick something greater than 3. How about 5? So let's test 5. And we will have 25 minus 5 minus 6 is greater than 0. And 25 minus 11 is 14 is greater than 0. And that is true. And so that is the conclusion of our testing. So what we think the answer then will be is this part is true and this part is true. And so the solution to this polynomial inequality will be from from negative infinity up to negative 2, and also in union with, let me plug that, from positive 3 to positive infinity. Now you notice it says greater than 0, not greater than or equal to. If it would have been equal to, we would have included this point. But notice if you put negative 2 in there, into this original, you get 4 plus 2 is 6, minus 6 is 0, and 0 is not greater than 0. So since it's just a greater than, we're going to go with the soft brackets. And we will include from this part right here and this part right here. This is your polynomial solution. Now, this is where the graphing comes in, not graphing like I just did. You know that this graph of this thing right here is a parabola. You know that parabola is going to cross at 3 and at negative 2, and you know because this is positive, it's going to go up. So eventually, into the next chapter, we're going to start looking at graphs as pictures of the solution, and anything that is below the graph is less than 0, and above the graph is greater than 0, so you can see that this is the part we want. From this point on, and from this point on. So this fits what we've done. But right now, we're going to use critical numbers to show. Okay, let's try another one because I know that's a little strange. Here is a second polynomial inequality. Let's solve it like we normally would. We're going to take the 2x squared and the 5x. And this one has a 12, so let's bring the 12 over and set it greater than 0. So there's our polynomial inequality. And we're going to try to factor this or solve it using the quadratic formula. And I'm going to be honest, I hadn't tried this one before, so I hope I can factor it. 2x and x will work. I need the factors of 12 that will produce a 5. And I think about 4 and 3. I'm going to stick the 4 right here, which will give me 8. I'm going to put the 3 right here, which will give me 3. And 8 and 3 will give me 5 if I make the 8 positive and the 3 negative. And all of this is greater than 0. So all that's good. Now, let's talk about critical points. The critical points on this graph would be the places where it would be equal to 0. So if we solve this, 2x minus 3 is equal to 0, 2x is equal to 3, and x is equal to 3 halves. 3 halves is a critical point, and x is equal to negative 4. Now again, let's just imagine these on a number line. Here's negative 4, and here's 3 halves. And what we know is that something happens on this graph in one of 3 spots, either here, or here, or here. When a graph has got 2 critical points, we'll have 3 areas to look at. Now, we need to check and see where, go back to the original, where is the value greater than 0? Okay, so we'll look. Let's pick a value that is on this side of negative 4. How about negative 5? Let's pick a value in between. How about 0? And let's pick a value greater than 3 halves. How about 2? And we're going to test these points. So let's test negative 5. Go back to the original. That's going to be 2 times 25 plus 5 times negative 5 minus 12. And we're going to see if that's greater than 0. So that's 50 minus 25 is 25. Minus 12 is 13 is greater than 0 appears to be true. So this part looks true. Now let's check 0. If I put in 0, I'm going to get 0 plus 0 minus 12 is greater than 0. Negative 12 is greater than 0. That is false. So not that part. And then finally let's test 2. And any point will do. So this is 2 times 4 plus 5 times 2 is 10 minus 12. It's supposed to be greater than 0. That'd be 18 minus 12 is 6. Greater than 0. That is true. So once again, the parts that we want for our solution, the solution set for this polynomial inequality, look at your number line, would be from negative infinity up to negative 4, soft bracket, and I'm using a union, but you can write the word and if you want, from positive 2 up to positive infinity. And it's not always going to be the left end and the right end and not the middle. Sometimes we'll see something else. But again, this part of the graph, this is a greater than, just like the last one, which implies why it looks like this. All right, let's try one more of these. All right, this is the hardest one yet. So this one, when we bring everything over, 2x cubed minus 3x squared minus 32x plus 48 is greater than, and there's nothing left over there, so let's do greater than 0. Now this has 4 parts. This is factoring by grouping. So let's group the first 2 and the last 2. The common factor here is x squared times 2x minus 3. And if we did this right, this will also graph to 2x minus 3. And to do that, we're going to have a negative 16 as a common factor between these two. Negative 16 will go into negative 32x 2x times. Negative 16 will go into 48 negative 3. And that's going to be greater than 0. So factoring, we're going to get x squared minus 16. Remember, factoring by grouping, you're going to bring both of these parts together and then set that equal to 2x minus 3 greater than 0. And let's look at our solutions. This is going to be x plus 4, x minus 4, and 2x minus 3 is greater than 0. Critical numbers here are negative 4, positive 4, and positive 3 halves. And you would expect 3 solutions because, after all, the degree of this was 3. So those are our critical numbers. Now that does not tell us what the solution is going to be, so let's just lay them out here. Here's negative 4, here's positive 3 halves, here's positive 4. So look at our possibilities. We have here, we have here, we have here, and we have here. We need to test points in each of those locations. Let's pick something easy. Here's negative 5, that'll do there. Here's 0, that'll do here. Here's 2, that'll do there. And here's 5. I know it's a lot of checking, and it will be much easier when you learn to use the graph. But anyway, here's what we would do. We would put each of those points in, and for time's sake, I'm not going to do all of those. I'm just going to give you the solutions that would work here. So when we test this area right here, we should get a false response. When we test this part in here, we should get a true response. When we test here, we should not work, and here we should work. And again, I'm trying to get this in my time limit, so I'm not going to do all that for you, but you can test. So what we want to do is we want to say our solution is from negative 4 up to 3 halves, and from positive 4 to positive infinity. That would be our solution. If you have any questions about that, see me. I've got 2 minutes and 30 seconds to get the last one in, so I'm going to do it very quickly. This is a rational inequality. Rational just means a fraction with an x in the bottom. Rational inequalities are going to also use critical points. We're going to look for critical points 2 places. We're going to look for those places in the numerator and denominator. Numerator and denominator that would give you a 0. Okay, so the first order of business, and I'm going to hurry through this one example. I'll have to talk more about this in class. 2x minus 7 over x minus 5 minus 3 less than or equal to 0. Need to get everything over a common denominator, which is x minus 5. Remember, this is 3 over 1. So that's going to be 2x minus 7 minus 3 times x minus 5. Okay, 2x minus 7 minus 3x plus 15 over x minus 5, all that less than or equal to 0. Simplify the top, you're going to have negative x plus 8 over x minus 5, less than or equal to 0. Now our 2 critical numbers are 5, that's what you get from the bottom, and 8. So imagine you're going to test. Here's 5, here's 8. You're going to test here, here, and here. You want to look for examples where the value is less than or equal to 0. And once you find those values, you are going to write them in interval notation. Now I'm going to stop the video so I won't run out of time. But we'll talk more about this in class. I'm not going to do any more videos. I promised. This is it. So I'll see you in class tomorrow to answer your question.